In this video we're going to look at angles in parallel lines. First thing we should be able to do is identify a set of parallel lines. So if we look at the question here, we can see that because of these two arrows, that's telling us that these two lines are parallel. So then we're going to look at angles in parallel lines. We're given one, we need to find this one down here, okay? There's a couple of different ways of finding different angles of parallel lines. I'm only going to give you one angle rule that'll be new. What we should recognize already is a couple of the simple ones, such as angles on a straight line add to 180 degrees. And actually I'm going to use that one now straight away, because what I've got here is, this is a straight line along here. The 45 and this angle up here should add to 180 degrees, which means I'm missing 135 degrees here. So those two angles here add to 180. And that's just using angles on a straight line. I can use that same angle rule to find this one here now, actually, because the 135 plus this missing angle here are again on top of a straight line. So this is 45 degrees, because these two need to add to 180 degrees. What you might notice is that that's the same as this one here. And what you've got there is you've got another angle rule, which is vertically opposite angles are equal. And because of that, I could say that the 135 degrees is going to be the same as this angle here, because they're vertically opposite. This is also 135 degrees. Hopefully you might have spotted, this is a point. These angles are around the point. So 360 degrees around a point. If you add these four angles up, it should give you the 360 degrees. What you need to absolutely have from this is that angles on a straight line add to 180 degrees. I can use angles on a straight line add to 180 degrees to find all of these angles here. So that's the minimum that I need. What I need to do now is get from these four angles down to this set down here. Now what you'll find is, and what I recognize is, these angles are all going to be the same down here, okay? But I need a reason to get down there. So this reason is going to be as so. If you look at this parallel line here and this line, what I've created there is a C. Funny looking C, but it's still a C, okay? So in between the two parallel lines and the same side as this line, what we call this is the transversal. So these two angles, we call them co-interior angles. My angle rule for that is co-interior angles add to 180 degrees. So actually we're using the same number that we use for angles on a straight line. Very easy to remember it that way. So we've got 45, which means this must be 135 degrees. You might be able to spot straight away how to get the X. If you can, that's brilliant. I'm going to find all these angles. Also straight line again down here, which means this is 45 degrees. The 135 is on top of a straight line again with this angle, so this must be 45 degrees. And finally X is equal to 135 degrees. You could get that any number of ways. We could use a straight line, that 45 here, and the X are on top of a straight line again. The X and the 45, they're underneath a straight line, so again need to add to 180. What you might have got straight away, the 135 and the X, they're vertically opposite. so they need to be the same, and that's why x is 135 degrees. It did say give reasons for your answer. We've already done that. The two key ones: angles on a straight line add to 180 degrees, co-interior angles add to 180 degrees. You can solve that question by using just those two if you wish to. Here we've got a second question. If you look at it, slightly different in terms of the transversal, it's leaning a little bit different, but I do have those two parallel lines. We've got one angle. We need to find this angle y up here, giving reasons every time. If you wish to, pause the video and have a go at it yourself, and then see how you did. So what I'm going to do first is I'm going to acknowledge actually that I'm going to use angles on a straight line add to 180 degrees, but they're parallel lines as well, and these angles are on different parallel lines. So what I'm also going to use is I'm going to use co-interior angles add to 180 degrees. Now if I can find the value for y, I've already stated my reasons here. And you're starting to pick up marks as well. If this is a test or an exam, you're using the correct angle rules and stating them every time. So 110 degrees, I can see that it's underneath a straight line here, so this must be 70 degrees on this side. I'm going to keep using straight line. So here's your straight line again. So I've got 70 plus something else is on top of that straight line. That needs to be 110 degrees. And then finally we've got another straight line here. So that's 70 degrees. And you can check it, add them up. They should add up to 360 degrees because they are angles around the point. Now to move up here. So I've got, here's my C for the co-interior. And we know that these two angles inside here need to add to 180 degrees, as we've already stated. I've got 110, which means I'm missing 70 degrees. I don't need to do any more. If I wish to, I could fill in the rest of these if I need to. So that's 110, that's 70. We'll see they're vertically opposite. And again, vertically opposite angles are equal here. And they still add up to 360 degrees. So that is it done. That is angles in parallel lines. Two angle rules at the very least you need to know. Straight line add to 180 degrees, and these co-interior, where they create a C, need to add to 180 degrees as well. What I should state is, these co-interior angles, it doesn't just have to be a C shape. It could be a backwards C like that. It would add to 180 degrees. So for example, here's my backwards C. And you've got there the 110 plus the 70 add to 180 degrees as well. So it doesn't have to be that way around every time. You could have it backwards. And in light of that, have a go at this question for yourselves. Pause the video and then see how you're doing it. Right, hopefully you had long enough to do that, and you've got a value for C. The first thing we should be noting is that we've got parallel lines here, so it's very likely I'm going to use angles on a straight line add to 180 degrees. Do not try and cut that sentence down. That's as short as we can make it. Make sure you state all of those words, the full sentence. The next one then we're going to use, because it is parallel lines, co-interior angles. Again, add to 180 degrees. So, the 115, I know that across from this here, these two need to add to 180 degrees. So I'm missing 65 degrees. Again, straight line along here, 115, I'm missing 65 degrees. And a very quick one if you needed to, vertically opposite angles here, so that's 115 degrees. So clearly what I need to do now is get from these top 4 angles down to these bottom 4 angles, so I can use co-interior. Either way is absolutely fine. Let's go with our forward C, like so. If you did it differently, that's absolutely fine. You should still get the right answer. So 115, this one down here must be 65 degrees. What I could do straight away now is recognize that Z and 65 are vertically opposite angles and get the answer straight away. Or we could go the long way and work out those straight lines again. What I'll do this time, actually, we'll go for vertically opposite angles. Z is equal to 65 degrees. If you didn't find these angles, you do now need to state that vertically opposite angles are equal. So 65 degrees is your answer. Minimum you need to have is angles on a straight line add 280, and co-interior angles add 280 degrees also. Hopefully you got that correct. And the video has been of some help to you. Thank you for watching.